TypeScript is an awesome language because differently to JavaScript, it actually prevents some really dumb mistakes and also enforces really good practices, which is quite nice. So it of course would be a shame if you didn't use it to its full extent. So let's take a look at how to use TypeScript properly with React. Okay, so let's start off simply. I've created a little Vite app using the React TypeScript prefab and removed all the content from this app component right here. And if we now just take a look and hover over here, we can see this is a JSX.element. So oftentimes this can be found out automatically, but sometimes it can't. And then you can just say, okay, .jsx.element, which will then allow you to actually use this component as a child, because if TypeScript is not able to find out that this is a JSX.element, then it will run into issues when you want to use this component as a child for another one. Most of the time though, this should be completely fine if you leave it blank, because as you saw, TypeScript found out that this is a JSX.element anyway. Okay, so now let's get a bit more advanced by actually using state. So const state and set state equals use state, and we'll just initialize use state as null. This would work perfectly fine now, but as you can see, it currently only accepts null. So if I were to create a function const on click equals set state to a, then that would still work, but it doesn't work in the way you might intend it to, because maybe you want to store numbers in here, and you of course want to prevent somebody from adding a string. So the way you do that is using generics. So here you can now say, okay, I only want this UseState to accept numbers. And now you can see both the null and the a are marked as false because neither null nor a are a number. If you want your component or your state to be nullable, then you will need to also add null as a type. And if you do that, then the null error will go away, but the a error will still be there. So if you just change this to a 1, then that will work just fine now. And for refs, this actually works really similarly. So const ref equals UseRef down here. We'll initialize it as null again and say our app div right here is gonna get that reference. So ref equals ref. And this will work because it can somehow determine this automatically, but sometimes it can't, and your autocomplete might suffer from this as well. So what you can do here is tell it that it only accepts HTML div elements, and now you get every feature from an HTML div element. This might be really helpful as well if you were using inputs, for example, which have more flags than a div element like a value and stuff like that. It would of course also work if you defined a second ref, const ref2 equals UseRef, and you for example want to store numbers in here. So we'll initialize it as null again and say it only stores numbers or null. But now you might have gotten this far, but tend to struggle when you need to pass this as props. So let's create a second functional component right here. So function prop drill, which takes props and also just returns a div. So here it now tells us as props is declared and never read, which is true, and that it has an implicit any type. And to solve that, we're going to need to define an interface called prop drill props. And in here we will now tell it what it can accept. So prop drill props, first of all, is a type of our props. And here we will accept children, which is a React node, which basically can be every React element. So a string as a child or a React component as a child, JSX element, whatever, all of this will work. We also accept a setState function, which we'll just call setState. You would of course give it a smarter name, but for this it will be plenty. And a setState is basically just a function that returns void, and it gets a setter as an argument, which is a set state action that takes in a type. And up here, we used number or null. So down here, we will do the same. And that's basically how you pass children and set state. But the set state is kind of ugly, so you might want to wrap it in its own type. So type state setter equals this. And now we can just tell the state setter what value we want here, because we of course don't want number null in here. So we can say state setter t equals t, because t is basically a generic type. So whatever you pass in here will also be passed in here. So we can now say that set state is a state setter, and this state setter accepts number or null. And now we've basically cleaned this up a bit. But how will we pass our ref now? Well, kind of simple actually. Our ref is just a ref object with the same type. So number or null. And that's basically how you pass the default React stuff as props. Okay, so now that we've handled normal state, let's get a bit more advanced by memorizing stuff. So const double equals UseMemo. And in this UseMemo, we'll just say state times 2. We'll of course have a dependency array that contains our state. And now, because we're using Typescript, it actually tells us that state is possibly null. So what we can do here is we say state or 0. And this works just fine. So now we have a memo that tells us here we've got double. And because we defined our UseState properly, we can now also get proper type hinting for our double right here, which can of course also only be a number because we defined that it's 0 times 2 or state times 2. You could of course also say that double is a number or null, in which case you could say state question mark state times 2, else return null. So you'll have to handle the null somewhere else. And for UseCallback, this works really similar to const who equals UseCallback. UseCallback takes an arrow function and of course a dependency array. The dependency array will never need to be typed in any way, which is kind of nice. But now you might want to tell React what return value your function will have. And if your function doesn't return anything, then you can tell it that it's void right here. Or if you return a number, for example, then you can also do that. Now we've got a function that should return a number, but it currently doesn't return anything, so it throws an error. So if we now just go ahead and say return 1, then everything works just awesomely. Or we could of course also use a state getter here, basically state, and we just return our state. This is not really a sensible function, and it does return an error because we currently have number or null as state. So now we can just say or null again, and this would basically be our safe state getter now, which is kind of awesome. And you could of course pass this as a function, just as any other function as well. Okay, so now that we've handled everything about normal localized state, let's actually get into globalizing state using useContext. So to do that, we can define a new context in a separate file actually, which will be the global context.tsx. We're going to say export const global context create context from React, and our context will be initialized as a null. So we've got a default type of null here, which we can handle later though. And we're also going to need to export an interface. So let's call it I for interface and then global context. And here we can just go ahead and tell it what our context is going to contain. And for simplicity's sake, we're just going to be handling numbers. So value is a number. And now we can also tell it that our context is supposed to be an iGlobal context. And now it tells us null is not assignable to iGlobal context, which is fine. So we'll just go ahead and say iGlobal context or null. We will handle this null later so that we don't need to handle it in every component, but for now, this is fine. And now we can just export our global provider, which we're going to wrap around our app later. And here we're first of all going to return global context.provider, which throws us an error because value is missing. So we're going to change that real quick. And here it also tells us what the value is supposed to be. So if I just add an empty object in here, then it will tell me that that is not going to work because we are missing the value. And to get the value, we can just say const value and set value equals UseState. Our state is of course going to be a number, and we'll just initialize it as 0 so that we don't have to handle the null in here as well. And now we can just pass this value right here into our object and everything is fine. And we could of course also go ahead and say set value is also exported, which will then again be a function. That function returns void, and of course takes a setter, which is of the type set state action number. And now we of course also need to set the set value in here, and of course also type it properly. And now the only thing that's missing is we need props again, which we could do using an interface again, or what we could also do, which is actually simpler for this, is we can just say children and then type these children by saying children React node. And this is basically how you define an interface inline, which for this kind of component is absolutely fine because it only accepts children. And now we can just go ahead, pass these children over here, and our component is done. So now we can just head into our main.tsx, wrap our global provider around here like that. And now we could actually already use it. So if we head to our app now and say const x equals use context, and we parse our global context in here, then this will work. But you can see that it's now iGlobal context or null, just as we defined in the context, which is kind of unfortunate because it will always be set, given that, yeah, we always pass these values. But the null needs to be initialized to not have any redundancy up here. So the way you can solve this is by actually defining a new hook called useGlobalContext. And what useGlobalContext is going to do is we're first of all going to export the function useGlobalContext. And what it is going to do is it's first of all going to use this context. So const context equals useContext, global context. And here again, we're going to see it's either null or iGlobalContext. So what we can do now is say if context return context. Otherwise, row new error. And this is basically how we handle the null, because in here we only got the iGlobalContext now, and if it was to be null, then we will just throw this error because, yeah, something must be wrong in our app, because we're probably missing a provider or have defined something wrong in our global context. So we just throw an error because it's not going to work anyway. And now if we just head back to our app and wouldn't use context right here, but use global context, then we can see X is just iGlobalContext, and we can replace it with value and set value, which also have the according types that we set before. And now there's just one type of vanilla React state handling left, which is the UseReducer hook. And to do that, we're gonna create a new file again. So person_reducer, because we want to work with a more complicated object now. So first of all, we're gonna export it again. So export function person_reducer. And this function takes two properties. One of which is the state, so our initial state, and the other one is an action. And for now, it will just return the state that it gets, because the way that the reducer works is it gets the initial state first of all, and then it manipulates and returns the new state. And the way you control it is using an action. So now let's first of all define what our state is going to look like. So export interface iPerson, and iPerson is going to have a name, which is a string, and an age, which is a number. So quite simple actually. What we can do now is just say state is an iPerson, and now we need to define the action as well. So export type person action. And for that type, we're going to have multiple ways to define it. So the way that works is we're going to start off with an or to basically tell it there are multiple properties here, look at all of them please. And it will always be an object, because action is always an object, which has two properties. First of all, a type, which will actually be forced to a certain string. In this case, we'll say set name, and our set name is going to take a payload, and that payload is of course going to be a string. And now if we just assign this here, we can say that every time the type of the action is set name, we will expect a string to be passed. And let's say we added another one, which is ink_age, then we of course don't expect a string, but a number. And the same thing if we want to decrease our age. So we can have the same object have different payload types depending on what key is set in here, which is kind of awesome. So now if we just look at our person action again, we can see this is working just fine. And now to handle all of these events, we can just define a switch case for action.type. And in here we can now say case, and it will already tell us what kind of options we have. So we'll first of all define the set name, and set name will just return our current state and set the name to action.payload, which works just fine because we defined it as a string up here. If we now went ahead and actually called this ink_age though, we can see that it still works kind of, because yeah, it doesn't know what it should return. So our person reducer should of course also return an iPerson. And now it will tell you that name is not assignable to the type number, which is absolutely right. But if we set it back to set name, then it will know that the payload is a string, that name is a string, and everything will work out just fine. So now let's just do this for the other two as well. So ink_age will be age, and then state.age plus action.payload, and the same down here, just with a minus. And you could also add a default here, which would either just return your state, or you might also want to throw an error because something went wrong and you passed something that you shouldn't have been able to. That's up for you to decide. So now let's just also use this. So const p equals UseReducer. The UseReducer, first of all, expects the reducer, so person reducer. And secondly, it expects an initial state. And our initial state is just going to be name Niklas and age 21. And now it also doesn't throw us an error because everything is right. If we defined this as a string, then Typescript would of course complain again, which is just what we want. And we can also see that here we've got an iPerson and a dispatch. So let's just format this correctly, person and dispatch person. And if we were to try to use dispatch person, let's say in a UseCallback again, then we can see we get person actions as an option. And if we were to say type is decrease age. Then we can define a payload, and it already tells us that this should be a number. So if we added a string in here, it would be a mistake again. But if we just said 1, then everything is fine. So we're decreasing the age by 1. So that is how you'd use TypeScript for good typing, following good patterns, and just avoiding dumb mistakes. And if you want to avoid more mistakes and have really reliable state management, then maybe you want to check out this video where I'll show you how to use state machines in XState to have really reliable and dependable state. So let's check it out.